The science that we're working on is geared at looking at hydrothermal systems on Earth as a means to explore and understand hydrothermal or other type of similar water-rock interactions on other systems in our solar system.
As you change the geology and the chemistry of these systems, then the microbiology at the base of the food chain of these systems changes as well. And so where that's taken a sudden new departure is into this new space research is really an area that only evolved over the last 2 or 3 years. I'm Chris German from Hole Oceanographic Institution, and I'm going to be the science lead on our SUBSEA project exploration of Loihi Seamount.
And I'm Darlene Lim, and I'm at the NASA Ames Research Center as well as the Bay Area Environmental Research Institute, and I'm the principal investigator of the SUBSEA research program.
So in the last 20 years or so, NASA programs like the Galileo mission to Jupiter and the just completed Cassini mission to Saturn has realized that there are moons of large planets in the outer solar system that also have liquid water oceans. In their case, they're covered with an ice cap, but underneath that ice cap, there are deep saltwater oceans, and in at least 2 cases, those saltwater oceans are in contact with a rocky seafloor.
So in our circumstance, we're actually looking at an interplate seamount that in the first year in 2018, we're headed to Loihi. And this seamount is really exciting to us because it's not a kind of traditional exploration data point. It's a means, if you will, of not only kind of ground truthing what we think we know, but also as a means to prepare ourselves for what we want to learn in the future and actually impact future missions to other ocean systems in our solar system.
For Enceladus, one of the moons of Saturn, the moon is so tiny that although the ocean is 5 or more kilometers deep, so really deep even by Earth standards, the pressures at the bottom are really just the same as a few hundred meters deep on Earth. So Loihi Seamount, which rises up to shallow water depths, is a really cool place to go and study for that purpose. So it's a really cool time to be working in this area, that suddenly we realize that everything we've been doing with things like the Nautilus, learning how to use robots and go and explore the seafloor, is exactly the planning mission that NASA would have wanted someone to have been investing in for the last 50 years, so that they would now know how they could go and do that in the outer solar system in future.
The architecture when it comes to telepresence is a wonderful model for future mission architectures when it comes to human spaceflight to deep space or to Mars. And so we're going to use all of these different sort of terrestrial means to learn, about future opportunities when it comes to getting ourselves into a position to do robotic exploration on other planets or else human exploration on other planets as well.